So as I mentioned before, understanding any software system can be improved if you take a look at its design and the relationship between the various elements in the design. And a very popular way to do this is to apply software patterns. And that's going to be the focus of this particular part of the lesson. So as you're going to see here in just a moment, we have a number of patterns that are applied, and these patterns come from different sources. Some of them are going to come from the classic design patterns book. You've hopefully seen that before in CS 251 if you took that here, which is typically called the Gang of Four book. But there's also going to be other patterns from other sources, such as the Pattern-Oriented Software Architecture series. And I was the co-author on a bunch of those pattern collections and pattern frameworks and so on. So let's talk about some of the patterns that are applied. One of the things people sometimes forget when they start applying patterns is there's many patterns to choose from. It's just like algorithms and data structures. There's many books out there that talk about heap sort and quick sort and heaps and lists and hash tables and so on. So you don't have to go to just one place to find out about your favorite data structure and algorithm. And the same thing's true about patterns. There's many different patterns, usually documented by people with different perspectives on the kinds of software they need to build. So for example, the Gang of Four book, which is the one kind of hidden over here, it's called Design Patterns, Elements of Reusable Object-Oriented Software. That book was originally written by people who were primarily working on graphical user interfaces. They had done other things too, but that was a lot of where their background had been. So not surprisingly, a lot of the patterns that you will read about in that book focus on the kinds of things you deal with when you're building a graphical user interface. Now, because they were very sophisticated and thoughtful software developers and researchers, they generalized from their experience with GUIs to cover other things. So the patterns that they documented are useful for lots more than just graphical user interfaces. However, the graphical user interface domain in those days, which was late 80s, early 90s, lacked certain things that we really take for granted today. Most importantly, concurrency and distribution, and security and fault tolerance and other things, real-time behaviors. So not surprisingly, as other people in other domains started to document patterns that were important for them, they started to realize there was lots more than just the Gang of Four patterns. So the Pattern-Oriented Software Architecture series of books covers other kinds of things, such as patterns for concurrent and networked objects, patterns for resource management, patterns for architecture, patterns for distributed object computing, and so on and so forth. And so those patterns also apply, some of those patterns apply to this example too, to the case study. Some of the patterns are very essential to the design. You really can't get very far without understanding these patterns. So one of the most obvious ones when dealing with streams and parallel streams is the classic pipes and filters pattern. And pipes and filters was originally documented in the POSA 1 volume called A System of Patterns. And then it also appears again in abbreviated form in the POSA 4 Pattern Language for Distributed Object Computing book. If you don't have either of those books and you want to learn about this pattern, take a look at this particular link, which was an article written by a colleague of mine named Bob Hanmer, who talked about pipes and filters. And the basic intent of this pattern is to divide up an application's tasks into various self-contained data processing steps, and then connect these steps together using intermediate data buffers in a data processing pipeline. And of course, that's really at the heart of Java streams, although they don't really have necessarily intermediate data buffers, but they are definitely connecting things together in a data processing pipeline. So if you think about what a Java stream is, that's exactly what it is. We've talked about that before. So that pattern is really important to understand when you're thinking about the design of this case study, and more broadly when you're thinking about the design and use of streams and parallel streams. There are other patterns important too. This is a pattern that was documented in the POSA 2 book and the POSA 4 book, and it's called future. And the basic idea of future is to provide a proxy to a client. So when it invokes an operation on the service, and the service is going to run asynchronously and concurrently in the background, that proxy can be used to keep track of the state of the computation of the service. And that's how we get the results to come back when the asynchronous computation completes. So typically what happens, you invoke an operation that's going to run asynchronously, and that goes and runs in a service thread in the background, and there's all kinds of ways to design that. Thread pools are commonly used here, of course. And right away, you get a future back, and the client gets the future, but the future really isn't good for anything, or isn't good for very much, until the asynchronous computation finishes. And at that point, the future can be used to redeem the result. And we'll talk quite a bit about futures, and I'll give you some cool metaphors that will be helpful to understand more intuitively how they work. But futures, as you might expect, are an important pattern when talking about the completable future version of the ImageStreamGang case study. And we'll talk a lot about that when we get to that part of the course. Another very essential pattern that we use heavily in the ImageStreamGang application, and other stuff too, is the resource pool. And the resource pool appeared in the POSA 3 book. Should actually be over here. The red thing should be over here. Patterns for Resource Management. And basically, it's used to amortize the creation of resources, the costs of creating the resources or destroying the resources, by pooling them together. And therefore, it prevents excessive acquisition and release of resources by recycling them when they're no longer needed. So rather than giving them back and shutting them down altogether, it puts them in a pool, and when they're not in use, they sit in the pool and wait for someone to come along to leverage them. And there's all kinds of things you can pool. In the context of the ImageStreamGang case study, we're pooling threads. So we'll have a thread pool, which for the case of the parallel version, the parallel streams version, is the common fork join pool. So the common fork join pool is an example of the resource pool pattern. So those are some of the most essential patterns. Then there's also some other ones that are a little bit more tactical, and they're what we would typically call design patterns. Some of these things, for example, pipes and filters is really an architecture pattern. It's how you structure the architecture. Likewise, the resource pool is an architecture pattern. It's how you structure the architecture. Other patterns are more design patterns, which is not to devalue them. It's just to say that they have a more limited scope over how they influence the design and implementation. And one of those patterns is the template method pattern. And of course, the template method pattern comes out of the Gang of Four book, the design patterns book, and it defines the overall structure of a method, which is the template method, and then it allows the subclasses to refine or redefine certain steps selectively and in a very careful and systematic way. And you'll see that we use this pattern. This pattern is used in general in frameworks, and we have this thing called the StreamGang framework, and the StreamGang framework provides the heart of the overall design of the ImageStreamGang program, and it's got some cool template methods that do a fixed set of steps that can be customized by subclasses that want to have variations in things like the concurrency strategy. So we'll see how that gets applied. It's a very, very, very popular pattern. Another very, very, very popular pattern is the factory method pattern, which again comes from the Gang of Four book. And it's used to encapsulate the concrete details of object creation inside of the factory method rather than exposing all those details to the clients. So as a result, the clients don't know and don't care how things are created. They just know how the results are going to work. And you see factory methods all over the place in Java. You see them with things like opening a file. You see them with things like creating a stream. And we use factory methods throughout our design as well to make stuff. And the real goal here is to, especially when you use inheritance and dynamic binding, you want to shield the client code from any lexical dependencies on the type of concrete subclass instances that are created, and let them only have to work through references to superclasses. And that way you can add and extend and change things quite nicely down the road. There's another pattern that's kind of cool called Decorator. And this is yet again another Gang of Four pattern, and it allows behavior to be added to an individual object dynamically without affecting the behavior of other objects from the same class. And this is a way of being able to take an object and then decorate it with other capabilities, but do it in a way that's transparent to the original base class or base object. And we're going to use this particular pattern to design the filtering mechanisms to be able to apply different filters to the images to transform them. And we do it with the decorator to keep it very clean and stylized. Yet another pattern that's applied is one of the more controversial patterns, but it does have its place. It's the Singleton Pattern. And the intent of this pattern is to ensure a class has only one instance and to provide a global point of access to it. And I typically use singletons in very limited ways, but one thing I like to use singletons for is processing of command line options, or command line arguments. Typically, when you run a program, you can customize its behavior by passing different flags on the command line. And my preferred way of handling that is to have this option singleton, and as soon as the command line is brought in through the main entry point into a program, I parse the command line parameters, if any, and I update my singleton for my options, and then I can use that throughout my program without having to pass around an options parameter to all the methods that I need to be able to customize through options. There are other things that are in Java that you could argue are somewhat examples of singletons, although they don't use the singleton pattern per se to implement them. For example, the common fork join pool in Java could be thought of as a singleton because there's only one common fork join pool. Yet another pattern that's really quite powerful and important is called command processor. And this is a pattern that appeared in the POSO 1 book. It's a little bit like the command pattern from the Gang of 4 book, but it has a little twist to it that's somewhat different than just vanilla command. In particular, what command processor does is it packages a piece of application functionality in an object to make it usable in some other context, such as later in time. You could queue them up for later processing, for example, for a history list. Or you could also run it in a different thread, either in the same process or in a different process in the same machine, or in a different process in a different machine. So command processor is really at the heart of what's often called message-oriented middleware, where you pass commands around from client to some service execution context where they're actually performed. And the command processor pattern is used in Android in a very interesting way when you want to be able to do some computation in the background to avoid blocking the user interface thread, but then get the result to the user interface thread so the user interface thread can display it. And so that's a common use of command processor in Android. So these are some of the patterns that we use in the case study. I'll try to remember to point them out as we go through the examples so you can kind of take this overall concept and then see how it's actually reified or applied in the context of the actual code. But I find when I look at software, if I understand the patterns, I feel a lot better about two things. Number one, I can get a better sense of what's doing what. And if people have actually documented their software using patterns, it gives me a much better sense that they actually know what they're doing, because it means that they take the concept of software design and architecture seriously.